our first chapter is junction diode, and under junction diode we are going to study about principle of diodes and VI characteristics of junction diodes. Okay, these are the few questions which may come in examination. Write down the differences between intrinsic and extrinsic semiconductor. So this question may come either of 2 marks or 5 marks, right? So intrinsic semiconductor, extrinsic semiconductor, based on the purity of semiconductor, intrinsic is called as pure semiconductor, extrinsic semiconductor are called as impure semiconductor. Based on density of electrons, intrinsics are density of electron is equal to the density of holes. In extrinsic, density of electrons is not equal to the density of holes. This is a very important point, that the density of electrons in case of intrinsic semiconductor are equal. Electron and hole has equal amount. Whereas in extrinsic semiconductor, they are unequal. Fine. Electrical conductivity. Electrical conductivity is low in intrinsic semiconductor and it is very high in case of extrinsic semiconductor. Temperature effect, dependence on temperature only, dependence on temperature as well as on the amount of impurities added. Last one is impurities, no impurities, trivalent impurity, pentavalent impurity. So these are the 5 points, and this type of questions may come in examination either of 2 marks or 5 marks. Fine. Okay, coming to the next question. Write down the differences between p-type and n-type semiconductor. In p-type semiconductor, trivalent impurities are added. In n-type semiconductor, pentavalent impurities are added. In case of p-type, the impurities are called as acceptor impurity. In case of n-type, the impurities are called as donor impurity. Why? Now, fourth number point is in p-type semiconductor, conductivity is mainly due to holes. This is very important, which are positively charged. In n-type semiconductor, conductivity is mainly due to electrons, which are negatively charged. Okay. What is bias voltage? Because I am going to use this word throughout this session. What is bias voltage? So look at here. Bias voltage is the amount of voltage that an electronic device needs in order to power on and function. So diffusion is the movement of matter from one point to another point by random molecular motion. You can see there are 3 beakers and we have dropped some amount of ink on the first beaker. After some time, this particular blue color ink has taken all the space in the water. Okay, the rate of diffusion of a substance is proportional to the concentration gradient of that particular substance. So after some times, it gets dissolved inside the water. Okay, that is called your diffusion process. Now tell me one thing. Do you need any additional force to mix this ink inside the water? It is mixing inside the water by the random molecular motion after some time. Okay. But one thing is that if you use a spoon and stir this particular water, it may happen that mixing of this ink with the water will be faster. That is the only thing. Okay, but we doesn't need that one. We need to understand the concept of diffusion. Diffusion is basically the process of 2 or different matters, okay, without any force or without any drift. Without any force or without any drift. Okay, we don't need to apply any force just to mix a single drop of ink inside a water. That is called your diffusion. So here I can use a word. A drop of ink is diffused inside the water. Okay. So this is a technical word and this is the word I am going to use throughout this particular session. Right? Okay, fine. Now coming to the actual topic. This question generally comes in examination either of 8 mark or 16 mark. Remember this one. This is a long question. Okay. And this question has already come in your semester examination in last 2 years. Right? What is PN junction? Explain the formation. This is a long question. Complete theory and explanation question. Okay. 8 to 16 mark you may get in semester examination. Okay. So look at here. When a p-type semiconductor, you can see, when a p-type semiconductor comes in contact with n-type semiconductor under controlled temperature and pressure, the PN junction formation occurs. Okay. So here it is written, the PN junction is a junction formed together by p-type semiconductor and n-type semiconductor material. The PN junction generated when one side of the junction is doped with acceptor impurity, which is called p-type impurity, and another side is doped with donor impurity, which is called the pentavalent impurity. This is the second number point. Third number point, the region where both N-type and P-type materials are joined together is called the junction. This particular line is called your junction. Remember this one. Okay. So PN junction diode looks like this one. This is the physical. When you go to the market and you ask for the diode, they will give you this particular material, which is black in color and one silver color strip at the end. Right. So this region is your black in color and this region is your silver in color. The black region is your anode and the electrode which is connected to the silver region is basically called cathode. Right? And just like another electronic component, just like resistor, a diode also has some electronic symbol, and this is the symbol. So this particular area is your cathode or negative. This particular area, the triangular area, basically is your positive or anode. So remember this particular symbol. Okay. So the moment you will understand, you will learn about the rectifier and other circuits of diode, you need to see whether it is connected in positive to negative direction or negative to positive direction. So as we discussed already that resistor is a non-polar device. Can somebody tell me diode is a polar device or non-polar device? Of course it is polar device because it has positive polarity as well as negative polarity. So it is 100% polar device. So you have to take care about this when you connect it in the circuit. You need to check which one is a positive terminal, which one is a negative terminal whenever you connect this particular device in a circuit. Fine. Okay. So here we discuss 2 points. When a p-type semiconductor comes in contact with n-type semiconductor, the PN junction forms. The junction line is the joining line of the p-type and n-type region. Okay. Coming to the next point. Now this is very important. All of you understand this one. This particular symbol is for hole and this one is for your electron. What are the minority charge carriers in p-type semiconductor? So the electron I am showing it with the negative charge and it is a minority, so I am showing with the less number. And in n-type semiconductor I am showing with the plus sign. So these are the minority charge carriers. Okay. Now what happens is that when a p-type semiconductor comes in contact with the n-type semiconductor, right, the electrons from the n side try to diffuse towards the p side. Assume that this ink is your n and this water is your p. When an n-type is connected with the p-type, electrons from n-type try to diffuse towards the p-type. In the same way, you can see here, the electrons from n-type try to diffuse towards the p side because they are connected, of course. Okay, two dissimilar metals are connected, so the electrons from the n side try to diffuse towards the p side. And in the same way, the holes from the p-type try to diffuse towards the n-type. Right, but I already told you that holes doesn't move. The movement of electrons in opposite direction is basically the movement of holes. Okay. So this much is clear. The diffusion of electron occurs from n-type to p-type and the diffusion of holes from p-type to n-type occurs. Okay. Fine. After some times what happens is that After some time, some of the electron will be depleted over here in the form of negative charge in the p side, and some of the hole will be depleted over here, right? The movement of hole to the n side and the movement of electron to the p side. Okay, this is p, this is n. Okay, and this particular region is created, this small region is created, this particular small region is created, right? And this particular region is called your depletion region or space charge region. The majority charge carriers in p region are holes, while the majority charge carriers in n region are electrons. So I have made like this: p has a majority charge carrier holes, n has a majority charge carrier electrons. Point number 2, when the junction is formed, the holes present in the p region are diffused into the n region. Holes from the p region will be diffused towards the n region, leaving behind the negative charge in the p region. Of course, if hole will move, there will be some negative charge, which then recombines with the electrons, resulting in negatively charged ions in the p region. So this is basically my negative charge in the p region. Now similarly, electrons present at the n region diffuse towards the p region, leaving behind the positive charge in the n region and recombine with the holes, creating positively charged ions. You can see these are my positively charged ions. As the junction is formed, each region of silicon crystal becomes depleted from majority charge carriers around the junctions. This region is known as depletion region, and this particular region is called your depletion region. Okay, so this depletion region has negative charge in the p region and positive charge in the n region. Okay, you can see here, these are the holes. These are the holes basically. Okay, these are the holes. These are the holes, and these are the electrons. These blue colors are electrons. Blue color dots are electrons. Now once the diffusion process occurs, we will be having some negative charge over here, because electron will move towards the positive p-type semiconductor and holes will move towards the n-type semiconductor, creating a region in such a way that positive charge will be here and some of the negative charge will be depleted here. Okay, so you can see here, this white color boundary, inside this white color boundary, this is called junction. This is my junction, and inside the junction we have only negative charge in the p region and we have only positive charge in the n region. Okay, so this is what happens when a p-type semiconductor is connected to the n-type semiconductor. That's it. In examination, what you have to write: when a p-type semiconductor comes in contact with the n-type semiconductor, the holes from the p-type semiconductor diffuse towards the n-type and the electrons from the n-type semiconductor diffuse towards the p side. Okay, due to this particular diffusion process, a layer of negative charge is created in p-type and a layer of positive charge is created in n-type, right? And this particular region is called your depletion region. So this is a 2-mark question in examination. What do you mean by depletion region? A diode can be connected in 3 different ways. Connect a 0-volt battery. Connect a 0-volt battery across the diode. 0-volt battery, what do you mean by 0-volt battery? Do the 0-volt battery exist in this world? No, 0-volt battery doesn't exist. If somebody is telling you that connect a 0-volt battery across the diode, that means he is telling that do not connect anything across the diode. And this is called your no bias condition. This is called your no bias condition or zero bias condition, when no external battery is connected to the diode. Okay, right? So this is my first condition. No bias condition is my first condition. So under normal condition, when there is no voltage applied across the PN junction diode, the junction is said to have an equilibrium state. So this is my actually equilibrium state. I have not connected anything. I have not connected anything, and everything is done because of the diffusion process only, right? This is because of diffusion process. What is diffusion process? Some of the electrons will move towards the p type, and some of the holes from the p type will move towards the n type, and finally a depletion layer is created, and this is my no bias condition. I hope it is clear. When I do not connect any battery, every battery has some positive terminal and some negative terminal. So you can see here, this particular region has negative charge, and this particular region has some positive charge. So this will behave like a battery. This is negative, this is positive. What is the voltage of this particular battery? When you do not supply any external voltage, okay, this is called external supply. This is called external voltage. When you do not supply anything, 0 volt, then only what is the voltage? There is a small amount of voltage can be seen in this middle, in this depletion region. This is negative and this is positive, right? Next, remember this one. There is a battery, there is a creation of battery in the middle, and the value of this battery is 0.7 volt if it is silicon type, and the value of this battery is 0.3 volt if it is germanium type. And this is very important. This is a 2-mark question. Okay, this is a 2-mark question. What is the threshold voltage of silicon type semiconductor, silicon type diode? So you will say 0.7 volt. What is the threshold voltage of a germanium type semiconductor or germanium type diode? You will say this is 0.3 volt. Remember, okay? Connect it with a meter. Connect it with a meter, voltmeter, and you will see there will be an indication of 0.7 volt over here. Okay, when it shows 0.7 volt or 0.67 volt, you will come to know that this particular diode is made up of silicon. And when it is 0.3 volt, then you can say this is made up of germanium type. Okay, so this is called the no bias condition. So this I told you already. The potential difference formed in that state is called the built-in potential, and the value is 0.7 for silicon and 0.3 for germanium. Okay, so you can see here, this is the battery, internal battery, which is created. We are not connecting any external battery. Remember this one. This is not an external battery. We are checking that what is the voltage across this terminal, and it is 0.7 volt. Coming to the second condition, that is a forward bias condition. Okay, in this case, what I'll do is that the anode is connected to the positive terminal of the battery, and the cathode is connected to the negative terminal of the battery. If somebody will ask you what do you mean by forward bias condition, then you will say in forward bias condition, the anode of the diode is connected to the positive terminal of the battery, and the cathode of the diode is connected to the negative terminal of the battery. This is called the forward bias condition, right? Now what is happening in forward bias condition? Let me show you. Okay, this is p type and this is n type. So hole and positive terminal will or repel each other. So if they will repel each other, the hole will move towards the junction. The negative terminal of the battery will repel electron. The electron will move towards the junction. The hole will move towards the junction in this positive side, and the electron will move towards the junction in the n side, negative side. Fine. Ultimately what happens is that the more and more number of holes will move towards the junction, and the more and more number of electrons will move towards the junction, neutralizing this junction, reducing the width of this particular junction. Okay, the junction becomes thinner, right? You can say, बोल सकते हो that junction का width पहले आप लोग का इतना था, this is the junction width. Now the junction width has been reduced. अभी आप लोग का junction width reduce होते जा रहा है. Okay, the higher will be the voltage. जैसे जैसे आप लोग voltage बढ़ाते जाओगे, this is a variable voltage. Initially let the voltage is 1 volt. तो junction का width इतना हुआ. Next you increase the voltage, the junction width will reduce और कम होते जाएगा. And finally it may happen that the junction width will be completely eliminated in the forward bias condition. What I said here is that if a positive voltage is applied to the P region and the negative voltage is applied to the N region, it makes the junction forward bias. This is the first point. Okay, this particular line I'll tell you later. Now, when a battery is connected in this way, both charge carriers, that means electrons in the N side and the holes in the P side, will attract towards the junction. That will reduce the width of the depletion region. The positive voltage applied at the P region will repel the holes. Similarly, negative voltage applied at the N region will repel the electrons. Okay. Now, what happens in this condition is, if the junction width is higher, the resistance will be higher. It will produce a very high resistance. High resistance means if resistance increases means the conductivity decreases or not? The conduction decreases. Higher will be the resistance, less will be the conduction. If less will be the resistance, the conduction will increase or not? So in the no bias condition, let this is a no bias condition, there will be a very high resistance at the junction. But in case of forward bias condition, there will be a very low resistance at the junction, right? So the same point is given here. It makes the junction forward bias, which exhibits maximum conductivity and low resistance. With increase in forward bias voltage, the conductivity will increase and the resistance will decrease. Okay. After some time, the current will start to flow. The current will start to flow like this, from positive to this and finally to the negative. This is how the current flows in the forward bias condition.